This example is an example of relative motion where we have two different vectors. In this case, one is a swimmer moving at 1.5 meters per second north, and then the current of the water moving at 1.0 meters per second east. We're going to use the idea of relative motion to figure out what the net result is here. So if we write down what we know, we have the swimmer's velocity relative to the water, and that's equal to 1.5 meters per second north. And then we have the water's velocity, and that's relative to, let's say, the ground or the surface or whatever you might be looking at. So here we have 1.0 meters per second east. And to make our lives a little bit easier, we're going to just say that north and east are going to be positive. Next up is to determine how we're actually going to calculate the velocity of the swimmer relative to the ground. So that's going to be equal to the swimmer's velocity relative to the water plus the water's velocity relative to the ground. And since these are vectors, this is a vector addition question, and we add vectors head to tail. So first thing you should do now that we have an idea of what it is that we need to do is to draw a diagram. So we have the first velocity here, that's 1.5 meters per second north. And then the next one is 1.0 meters per second east. So we have our resultant vector. It's going to look something like this. And that's what we're solving for here, right? This vector here is the velocity of the swimmer relative to the ground. So this is a simple Pythagorean theorem question. So we have SVG, and that's equal to the square root of one side squared plus the other side squared. So 1.5 squared plus 1.0 squared. When you solve that, you end up with a resultant vector of 1.8 meters per second. Now we also need to know this angle. Because it is a vector, we need to give it some direction. So that angle inside of the triangle is the inverse tan of 1.0 over 1.5, which leaves us with an angle of 33.7 degrees. So we would say that, therefore, the velocity of the swimmer relative to the ground is going to be equal to 1.8 meters per second north, 33.7 degrees east.